Hello, welcome back everybody. MPLS VPN walkthrough tutorial. In this tutorial, we're gonna implement the communication between Japan and London. So first, what we're gonna verify again is make sure that we already set up the OSPF as an IGP MPLS VPN backbone, and then on top of that, we run the MPLS, and then we disable the default no BGP default IPv for unicast, and then we set up the MPBGP here. So let's verify again, is there already MPBGP is already set up between the router 6 and 7. So I believe it was already done. So 6 and 7 here. So I'm gonna verify is the MPBGP is already up. So I'm on a router 6, show IPBGP, VPN before all summary. So it's already up between router 6 and 7 here. And we can verify back the configurations for the MPBGP. So here we have with the router 7, MPBGP is already done. Okay, after that, what we're gonna do is we're gonna be running steady route from Japan customer routers to the P routers. So what we're gonna do, we just put the normal default route on the Japan. So is we go to router 13. So we verify the config, and then yep, IP route. We configure the default route pointing to 192.168.63.1 is here, and then we're gonna verify on this London side, which will run the BGP, which is on the router 14, and we go to router 14 here, and we just configure the router BGP 65444, and then we advertise the network 172.16.14.0, which is the local area network of the London, and then the neighbor is 192.168.74.1, which is this router 7 here, and the remote ASX85. So all the CE routers configuration is done on the Japan and the London. So the next steps we're going to be verifying on the router 6. We'll be running steady route. We'll point to the Japan LAN network, and also the router 7 going to be establishing the BGP relationship with this guy. So we go to router 6 here, and let's verify we have done any steady route, but no, not normal steady route, which is a VRF steady route. So yeah, we have done IP route VRF JPN, part of the VRF 172.16.13.0, which is the local area network of Japan, and pointing to 192.168.63.2, which is the default gateway here. Make sure before we do that, we've already created the IPVRF JPN, and also we have to put this interface first than 0/0 into IPVRF forwarding Japan. So we can verify using the show IPVRF command by verifying this one, as well as we can do the show run interface first than 0/0. We can verify the command is here. Alright, then let's move on to the router 7 here. And router 7, we're supposed to configure the normal VRF configuration. So what we're going to do is show IP VRF, and we already configured the London VRF, and we have already put the first unit 00 into the VRF LON. So we're going to verify again here. First unit 0/0 is already done here. And also we need to configure BGP with this guy. So what we're gonna do here is I've already prepared the configuration, and here we go, and it's on the router 7, which is from here, which is from PE4 router 7. It will be here, PE4 router 7, we're going to be configuring address family IPv4 VRF London. Neighbor is going to be 192.168.74.2, remote is 65444, and this is going to be activated here. This command. This configuration will establish a neighbor relationship with London, so that this router 7 will receive the local this advertised routes from London. So what we're going to do here in the router 7, and we can put in the router BGP 85, and I'm going to paste this configuration. Then after that, we can verify show IPBGP VPN summary. We can verify yup. So we already up 192.168.74.2 here, and we receive this prefix is 1, which is the local area network of London, which is 172.16.14.0/24. We can verify by using show IP route VRF LON. We receive the BGP routes here. Okay. After that, we will be verifying on the router 6 here. Show IP route VRF GPN. Okay, we have the steady route, which is pointing to 172.16.13 here. Okay, the next step's gonna be verifying the RD from this route for the router 14 here, for this one to transform to the VPN-v4 routes. So let's do standardize. Let's check what we have configured the RD value on the router 8. Show run. Okay, I use the router name as the RD value. Okay, so we go back to router 6 here. So I'm gonna verify show IP VRF JPN. I define the RD value as 1313, and then we go to router 7 config T IP VRF LON. I define the RD as 1414. Alright, so and then we can verify show IP BGP VPN-v4 all. So it's shown as this guy, and we can clear the BGP. So this is on here. Show IP BGP VPN-v4 all. So let's wait for a while. It comes up. So now it's updated in the 1414 for the London. And for the router 6 here, oh sorry, so I'll be BGP. No, it's not BGP routes on the router 6. I'm sorry. This is where we steady route show IP route VRF GPN. So we have steady route here. Okay, so now comes to the route redistribution parts that we need to do. So in this case here, we don't need the route redistribution between this London and here. Why? It's because we've run this is a BGP running AS65444, and this is running BGP running AS85. So we can see this two as eBGP relationships. So we don't need to redistribute routes from here. In here, we need the redistribution because we're running steady route here, and we are running BGP here. So we need to redistribute this steady routes into the BGP, and so I have the notes here. Alright, so here we need to redistribute the static and also connect it into the BGP. So what we're going to do here is we go to the router 6. config T, router BGP 85, address family IPv4, VRF, JPN, and then redistribute static route, so that we can see show IP BGP VPN v4 all. We will see 172.16.13, which is the local area network of Japan, into the BGP table. Okay. All right. Now, so the redistribution is done. So let's verify on the router 7 here. It's already get this route. So the next step is going to be this 172.16.14.0 will have to pass to this guy, and this guy passed the route to this guy. So we already run the MPBGP, but it still didn't share the route yet. So what we're going to do, we need to define the route target. As I mentioned in the previous tutorial, from here we need to configure the route target from here to here into MPBGP. We use the export commands. So what we're going to do here, so router 7 here, config T, IPVRF-LON, route target export is I define as a 4.4. And then after that, this London routes go into the 4.4, and then so it will be going to here to go to Japan as import value 4.4. So here, config T, IPVRF GPN route target import 4.4. Same thing, route target export. I want to export the route target of the Japan as 33, and I'm going here, route target import 33. Then we verify show IP BGP VPN v4 all. And here import and export is done. Show IP BGP VPN v4 all. Okay, so now we've learned this guy. And then we could verify here, show IP BGP VPN v4 all. We received the router 7. This guy now received 172.16.13.0, which is the local area network of Japan from this guy. The next hop is 6.6.6.6. Okay, then after that, the next step is going to be this guy is already, router 7 is already set up the eBGP neighbor with this guy, so this router 7 will pass this 172.16.13 route to this route R14. So we can go to R14 here, and we can verify show IP route as the BGP. So router 14 learns 172.16.13.0 from this, which is the route of the Japan as a BGP route, because they run BGP here. On the router 13, it's already configured the default route. So whatever this one, whatever it will goes to here. So from here, from Japan, whether Japan, this one will go to here or the other PE other side. So will be controlled by route target. So that's why I mentioned in the previous tutorial, route target is very, very important. Okay, so now we can verify here. Japan here will ping to the London, which is London local area network, which is the 172.16.14.14 source loopback 0 from Japan. Okay, I can be able to reach. If we ping this way, ping 172.16.14.14, it's going to be failed because router 13 initiate the packets from here, because just now when I redistributed, I didn't redistribute the connector routes. I just redistributed the steady route, so it will be failed. So what I'm going to do is I will ping the 172.16.14.14 to 1000 and then after that I need to redistribute the connected, which is a basically steady route concept. you have to be familiar with steady route. So config T route BGP85 address family IPv4 VRF JPN redistribute connected. So let's ping here. So first it's going to be, it will fail because we haven't redistributed the connected routes yet. But from the router 14 we can ping 172.16.13.13 source loopback 0. Okay, and also we can ping. Nope, we cannot ping because we didn't redistribute the connected yet. This one 192.168.74. Okay, so now it's let's verify this one is repeat, and now I'm gonna redistribute connected. So let's wait here and see here. So we can verify the routes here. Okay, now it's up. When I delete back this command, it will be gone. Okay, so now this router 14 known the routes of 192.168.63, which is a segment of this guy and this LAN here. So that's why it's now okay. Let me try to delete back. It's gone. Okay, so this is steady route concept. If you're not sure, so you need to pause the videos and you have to back to the steady route and think again and test it again so that you will get the concept of why we just reconnected. So it's failed now. I put it back. Okay, now it's fine. All right, and then let's move on to this guy here. So when I ping 172.16.13 from the router 14 here to this guy, when I ping from the source, it's fine, but when I ping this way, it's failed. So I'm gonna ping 1,000 packets, so it's failed. What we're gonna do, we need to redistribute this guy into here. So we need to go to here, this guy on the router 7, which is P, config T router BGP85, address family, IPv4 VRF, LON, redistribute connected. Redistribute it, and we can verify here. So let's, okay, this guy is already done. So no need to verify because it's a steady route. So he's here, he's up. So when I delete back, it's gone. Okay, now, so I'm gonna put it back here. Okay, so now it's already done. So the communication between London and Japan is fine now. Okay, so now the next steps I want to do going to be communication between the Japan and the New York. So I want to have communication between Japan and New York. What are we going to do? Well, we just need to play with the router export command, import export command. So let's go to the this router 12. New York is connected to router 5. So which is on the router 5 here. So we can verify. In the New York, I export the routes at 2.2. So what we're gonna do, it's on the here we just import the 22 into here to Japan. So I need to go to router 6, config T, IPvrf JPN, route target import 22. So because NYC defined as 22 export and go to Japan as 22, and then Japan export the route is 33, so I need to go to the New York, IPvrf NYC, route target import 33. So that the communication between Japan and New York can be able to reach. So we go to Japan, which is router 13 here. So I can ping to, which is New York local internet network is 172.16.11.11, 172.16.11.11. Source playback 0. I can be able to ping. Same thing from San Francisco, sorry, from the New York, which is on router 12. Can be able to reach to Japan local area network. Japan local area network is here, 172.16.13 or 13. So I can verify with here the routes. I can see here 172.16.13 routes as the EHW because this guy runs EHW. So ping 172.16.13 or 13. So playback 0. I'm good, and even if ping this way, also I'm fine. All right, so now that I can be able to, in this tutorial I set up the communication between this guy, and also from this guy to this guy, Japan and New York. Okay, the next steps, what I'm gonna do, I'm gonna play the route target again for practice. So I'm gonna set up the communication between the London and the San Francisco here. What are we gonna do? We just play with the route target, very simple. So we already learned that we already configure route target export 44 here as a London. So what we're going to do on the router 5, we go to San Francisco one, we go import 44. So we just go to the router 5. We go to San Francisco, and route target, what we're going to do is import 44, which is a London. So San Francisco become this like this. San Francisco export its route as 11. So what we're going to do is we just import the 11 to London. So London PE is on router 7, PE is router 7, which is a PE4. So what we're going to do is config T, IPvrf, LON, route target, import 11, so which is the San Francisco. So the config of the VRF will become, London VRF will become like this. Okay, so the communication between London and San Francisco is already established. So let's verify. Let's go to the route 14 here. So show IP route. We supposed to able to receive San Francisco is 172.16.11. Okay, here we receive 172.16.11, which is a San Francisco local area network, and also the 192.168.50.1.0, which is the communication between the P and CE of the San Francisco. All right, and we can verify on router 11. Router 11, when we verify the show IP route, we will receive this 192.168.74 and the London 192.170.16.14 network as the RIP. Here we go. and we can ping 172.16 11.11 and the source group at 0. So now this is the concept of the route target theory, concept of the route target, and also explain how do we configure in the real world, in the lab, and how do we configure, how do we verify. So now everything in one, all in one, and we go to router 14 here, and let's verify from router 14, which is in London. We're going to ping to 172.16.11.11. So we are good. So in this tutorial, what we have done now is communication between London and Japan is up, Japan and New York is fine, and London to San Francisco is good. If you want to set up the communication between the Japan and Yangon, what we're gonna do? We just play with the route target. Simple as that. So let's play for practicing. So Yangon is we export the route target as 55. So what we're gonna do is we go to router 6 here. So IPv4 route target import. We're gonna be import the route target 55, which is the Yangon route, and we go to route 8, which is the PE5 IPVRF 1GN, and then we go to the route target, and we will be importing the value of Japan, which is the 33. So 33 here. So the communication between Yangon and Japan is up. So now let's go back to where is the P routes. Oh. Okay, here. So we can verify from Yangon, which is on router 15, can be able to reach to Japan, which is a 176.13.13. We verify the show IP route. Here we go. So Yangon is now connected to Japan 176.13.13, and also source payback 0. Good. And from Japan, which is on 13, I can ping to 172.16, 15.15, which is Yangon. I'm good now, and source payback 0 also fine. Alright, so now in this tutorial we play with the route target a lot to be familiar, and then the next steps in the next tutorial we will left to do to set up this this guy and this guy, Singapore side 1 and Singapore side 2, which is pretty simple because we already done it here. And then in the next steps, what we're going to do is AS override concept, which is because we have the 65444 here, and we have another customer in the 65444 here. So the AS is going to be the same, so that we need to configure the AS override. I'm going to explain in the next tutorial. All right, so thank you very much, everyone, and see you in the next tutorial.